Hello everyone, welcome to the Gate Academy. My name is Aishwaresh and today we are going to start with Industrial Engineering Score Booster session. So I hope your preparation is going on well and all of you are in revision mode, right? So only few days are left, or I can say exactly 1 month, okay? It is left and everybody's preparation is going on well and I hope so, okay? So these score booster sessions, these are especially for revision purpose only. So basically these score booster sessions are concept through questions kind of sessions. Okay, that means we are going to solve some questions, and with the help of questions, I'll try to revise your concepts. Okay, so what are the important concepts which are there in a particular chapter or in all the chapters, entire subject? So I'll be taking some very good high quality questions, and with the help of those questions, the important concepts of that particular chapter will be cleared. Okay, so I think this will be the best way to do the revision, because if you take book and if you sit and if you go on studying, that will not help you much. Okay, so if you solve some questions and with the help of questions, if you try to recall the concepts and if you try to revise the concepts, then it will be the best way for your revision. Okay, so this industrial engineering subject, it is divided into two parts. First part, so definitely we are going to cover in today's session, and the second part will be in tomorrow's session. Okay, so it is on 7th. So I hope you are having the schedule, and you can go to the schedule and you will come to know what are the timings of these particular sessions. Okay. And just before starting the session, let me ask you, let me tell you. So so sorry for that. Please try to share these sessions with your friends who are preparing for the GATE examination, and you can also you can also subscribe to our YouTube channel, so that whenever we conduct these type of free sessions, you will be getting the notification for the same. Okay, so let us begin our session, Industrial Engineering Score Booster session. So let me see how many of you are live. So you can just say hi, hello, so that I can expect answers from you, right? So very good afternoon, Vijay. So I think I have to refresh. Let me refresh it once. So hi, Sai Krishna. I think you are Sai Krishna, right? So I do remember. Sorry. Okay. So many people are there. So hello everyone. Good afternoon. Good afternoon. Good afternoon, Rana Mukherjee. Good afternoon, everyone. So this particular industrial engineering subject, it is very simple subject. Okay, very simple and very scoring subject, I can say. So whatever the questions which you get from this particular subject in the GATE examination will be very simple and straightforward questions. Okay. So in most of the times, in most of the cases, you can expect only straightforward questions from this particular subject, industrial engineering. I can understand that in 2020 they have asked little bit, tough questions, not tough questions, I can say. So from new concepts, they have asked some questions. Okay. So that's what I can say in 2020. So if you exclude that particular, 2020 paper, so remaining all other papers, if you see, all other years, if you see, so all the questions are pretty much simple and straightforward questions. So that's why I say this particular subject is a very much scoring subject. Okay. So most probably in today's session, so I have divided the chapters for both the sessions. Okay. So as I said, two sessions will be conducted for this particular industrial engineering subject. So today we'll be starting with network models. Okay. And we'll see some questions from network models, and with the help of questions only, I'll try to revise your concepts. Okay. So then I'll start with linear programming. In linear programming, I have included all the things, right? I mean, graphical method, okay, and simplex method, transportation assignment, everything will be coming under linear programming chapter only. Okay. So it will be a little bit difficult to solve questions from all the topics, right? So what are the topics which are important, okay, or which I'm expecting, okay? So which I'm expecting that they can ask question from this particular topic in the next GATE examination. So from those topics I have taken, or I have tried to frame questions, okay? So if possible, we'll start with, queuing theory also. Queuing theory is a very simple, small chapter, but very important for GATE. So if possible, I will try to start. Otherwise, we will see that queuing theory in the next session. Okay. So this network models and linear programming, very important for GATE examination. And when I start with the questions, meanwhile I'll discuss what are the important topics of a particular chapter and which topics you have to cover first, right? And which topics you have to cover last if time permits. So all these kind of things I will try to discuss in this particular session. Okay. So let us begin our session. Good afternoon, Ashutosh. Good afternoon, Kuldeep. Okay, so I think many have joined the session. So please take your copy and pen and try to solve the questions along with me. And one more thing, I think everyone knows this, but still, okay. For the new students, I have to remind, this PDF will be shared with you. Okay. So the PDF of the questions or whatever I'm writing now, right? So that PDF will be shared with you. So do not worry about, copying the things from the screen. Okay. So try to spend more amount of time on solving the questions. Okay. And one more thing, not all the questions, few of the questions which I'm going to take now are conventional type of questions. So I have tried to, take mixture. That means some questions are conventional type questions and some questions are, pretty much straightforward questions, which you can directly expect in the GATE examination. That means similar type of questions, okay, you can expect directly in the GATE examination. So some questions are of that type and some questions I have taken, conventional type of questions. Okay. So the reason for taking the conventional type of question is very much simple, because if you solve a conventional type of questions, a lot of concepts will be revised. Okay. Or I can cover a lot of concepts with the help of a conventional type of question. Okay. So if you solve some 3-4 simple questions and if you solve a conventional single question, then both are equivalent, right? Sorry. Okay. So let us begin with the first question, which is from network models chapter. So in network models chapter, the very important topic will be CPM. Okay. So in most of the times you can expect question from CPM topic only, which is critical path method. And after that, maybe you can expect questions from project crashing also. So it will also be under, it will also come under CPM topic only, project crashing, because we are doing crashing only to CPM networks, okay, deterministic projects, okay. And after that, if they want to ask a question, I mean, if these two topics are missed, they can ask a question from PERT also. Okay, so PERT is probabilistic model. Probabilistic projects will be discussing in PERT. Okay, so most important topic is CPM. So you just cover CPM and crashing first, right? And after that, you try to cover the PERT. Okay, so apart from this, one small topic is there in this particular network models, which is network flow models. Okay, so network flow models, it is a very small topic where you will be seeing, or where you will be studying two algorithms. So the first one is minimal spanning tree algorithm, and the second one is shortest route algorithm. So very few questions are there from these two algorithms in the GATE examination. If you see past 30 years of papers of GATE, so only 2 times they have asked question from these two algorithms. Okay, so one was in 2008 and one was in 2014, I guess. So after completing these things, CPM, PERT, and then crashing. So after completing these things, you can go for that particular network flow models also. Okay. So, but first try to complete these things. Okay. So these are the important areas of this particular chapter. So I have taken 2 questions from this particular chapter. Okay. So one is from project crashing. I am expecting a question. Okay. From project crashing. And the second one, I have taken one more question from PERT topic. Okay, so let us solve the first question, which is on the topic project crashing. So as I said, it is a conventional type question, so do not get worried about the length of the question. So try to solve this question, and most of your concepts will be revised, which are related to CPU. Okay. Okay. So if you want me to scroll down, I'll scroll down. So I'm just giving you a few seconds of time, okay, to just look at the question and try to figure out what you have to find in this question. Okay. Okay. So what they are asking in the question? The management of a company is interested in crashing of the following project. So there is a project. Okay. So the management is interested to crash that particular project, right? So find the following. So the first part of this particular question is the minimum cost of the project and the associated duration of the project. Okay, so in the first part itself, you have to find out the two things, but both are depending on each other. So if you find one, other will be automatically found. Okay, so you have to find out the minimum cost of completing this particular project and the associated duration of the project. Okay, so as you all know, whenever you are doing crashing of any project, we don't know whether the cost may increase, it may decrease, or it may remain constant also. Okay, so you might have seen that particular curve, total cost curve. So do you remember? So first it will be decreasing and reaches minimum, and then again it increases. Okay, so it depends on the situation, it depends on these particular data which is given in the question, right? So coming to the next question, what they are asking in the next question. So in the next question, they are saying that if the management wants to complete the project one day earlier than that of the time associated with the minimum cost. That means whatever the time which you found in the first part. Okay. So if you want to complete the project one day earlier, okay, one day earlier as that of the time which you got in this particular first part. So what will be the additional cost incurred? Okay, so this is what they are asking. So that means whatever the minimum cost, at minimum cost you will be having particular project duration, right? So let us say it is 30 days. Okay, so if you want to complete your project in 29 days, then what will be the additional cost? So definitely the cost will increase. Okay, so you have to tell the additional cost, not the final total cost. So please remember this point. Okay, so compared to this particular minimum cost, what is the extra cost which is incurred to complete the project one day earlier? Okay, so it depends on the customer, deadlines. If you want, if he is willing to pay additional amount to reduce the time, it is his wish. Okay, so let us solve this question. First, draw the network diagram, and then try to find out the critical path duration. So very simple network diagram you will be getting. So I have not complicated the network diagram because that was not the purpose of discussing this crashing. So let us say 1 to 2. Okay. So 1 to 2, let us assume this is activity A. Okay. So for activity A, there is no predecessor. So I just have started activity A, right? Now you can see for activity B and C, there is a predecessor activity, which is activity A. So very simple meaning. So the meaning of this is after completing activity A, you can start activity B and C, right? So after completing activity A, start activity B and C. Okay. So I always tell this to the students, do not represent end nodes. Okay. So if you represent end nodes, then you will be complicating the things. Again, you don't know after proceeding further. So which activities you will be joining. Okay, sometimes it may happen two or more than two activities. You will be joining at a single end node. So these things will happen. So that's what that's why I always say that do not represent the end nodes. Okay. So activity BC we have started after completing A, right? Next you can see D is having a predecessor of activity B. That means after completing activity B, you have to start activity. Okay. So after completing activity B, I am starting activity. Okay. Now you can see after completing C comma D, you have to start activity E. Okay. So whenever you are having two or more than two activities under this particular predecessor column, what you have to do, you have to join them at a single node. So CD, so after completing CD, you have to start activity E. So join CD at a single node. Now do not worry about this, you can use any arrow. Okay, so do not worry that only straight line I have to use, straight arrow I have to use. No, any type of arc you can use, there will not be any issue. Okay. So let us say this is activity node number 4. So node number 4 represents completion of both of these activities C and D. Okay. So after completing activity C and D, you have to start activity E. Okay. So this you can represent it as node number 5. Okay. Now, so I hope you understood this network diagram. So if you are having any doubt in constructing this network diagram, you can definitely ask. Acha, so minimum cost is I'm getting answers also. Okay. So let us see what will happen. So A, B, D, E. So this is your one path, right? And A, C, E. So there are only two paths. Very simple. Okay. So please let me know what is the duration of these two paths. So I think it will be 35 and 34. Do not worry, I'll show you the things. Okay. So ABDE, ABDE is one path and ACE is one more path. Okay. So you have to consider the normal time, right? Normal time. So A, B, D, E. Acha, so you are getting 36. So let me see. It will be 19, 41, sorry, 19, right, 36. So it will be 36. So my mistake. Let me clear this. Okay. So 36 and 35 you are getting. Please confirm them. So this is 36. I have calculated also. 36 and you will be getting 35 maybe, right? So ACE, if I look ACE, so A and C, okay. So 7, this becomes 9, 29, 29, 6, 35. Right. Okay. So now your critical path duration will be this much, 36. Okay. Now, so in most of the times, what will happen is in the gate examination, they won't specify how many number of days you can crash a particular activity. Okay. So in most of the times, they will not specify these things and they will not complicate the things. Okay. So there is one more concept, where you have to find out the limiting. I mean, what I can say is the maximum duration which you can crash a particular activity, that you have to find. Okay. So for that, data is given. So look at this particular data. So each and every activity will be having its limit. Okay. So you cannot crash any activity, unlimited times. Okay. So you have to calculate these two parameters. So one is the number of days which you can crash a particular activity. And the second thing is cost slope. Okay. So what is cost slope value? So cost slope is the additional cost incurred, okay, per day to reduce the duration of any activity. Okay. So cost slope, for calculating cost slope, you are having a formula. So let me write that particular formula. Crash cost minus normal cost divided by normal time minus crash time. Okay. So crash cost, will be more. So crash cost will be more and normal cost will be less. So normal time will be more and crash time will be less. So ultimately you will get this cost slope value as positive value only. Okay. So cost slope value is always positive. So it represents how much extra you have to spend. So for crashing an activity by a single day or week. So here I think it is in terms of weeks. I'm sorry. Let me clear this. Here it is given in terms of weeks, right? So please make this also as week. So let's not complicate the things. Okay. Now, so you can see, let us find out this number of days. So normal time is 7 and crash time is 6. Okay. So 7 minus 6 will be 1. That means maximum you can crash this particular activity by 1 day. So there will be some restriction. Okay. So if nothing is mentioned in the question, you can crash as your wish. So already you can see the GATE previous year questions where they have not mentioned, this particular data. Okay. So if this limit is not mentioned, then it is your wish, you can crash as many number of days as possible, depending upon the situation. Okay. Now similarly, 12 minus 9, it will be 3. So this will be 1. And what about this 1? And this will also be 1. Okay. So I hope you got this point. So these are the limiting number of days. Okay. So you can crash activity A by only 1 day. B, you can crash up to 3 days. Okay. And C, D, E, so on. Okay. So now let us find out the cost slope value. So before that, let me, write normal time, crash time, normal cost, crash cost. Okay. So quickly give me these values. It is very simple. You can simply calculate. Okay. So you can see crash cost is more, normal cost is less. So 3000 divided by 1. So I'm not looking at you at that. I mean at your comments. Okay. So 13111 I have written. Okay. So Harsha Somala, any doubt in that? So next you can see 14,000 minus 11,000. So it will be 3,000. So 3,000 divided by 3. Is it okay? So 3,000 divided by 3 or this difference. So formula already you know. So it becomes 1,000, right? So next it will be 19,000 minus 18,500. So difference will be only 500 rupees. So 9,000 minus 800. So it will be 1,000, right? And 4,500 minus 4,000, it will be 500. Very good, Vijay. 3,000, 1,000, 500, 1,000 and 500. Very good. Okay. So this is the additional amount which you have to pay. So rupees per week. Okay. So generally we come across the questions where the duration will be given in terms of, days generally, but here it is given in weeks. Do not worry. Okay. So if you want to crash the activity A by 1 week, then you have to spend additional amount, which is rupees 3,000. Okay. Chalo. Now, so let us calculate the total cost of the project. So the first step which you can do is you have to calculate the total cost of the project. So total cost will be, total cost will be equal to direct cost plus indirect cost per week, direct cost plus indirect cost per week into number of weeks. Okay. So direct cost, as you already know, your total, your project will be having two types of costs. Okay. So if you can see, your total cost curve will be somewhat like this, right? So it reaches minimum and then again it increases. Okay. So if you see total cost and if I take time over here, okay, so it will be somewhat like this. Okay. So if you go on crashing, so if you perform crashing, then what will happen? So your direct cost will start increasing and your indirect cost, I am talking about total indirect cost. So total indirect cost in the sense indirect cost per week into number of weeks. So that will be your total indirect cost. Okay. So whenever you are crashing any project, your direct cost will increase and your indirect cost will decrease. Okay. But you have to balance these two things, right? So that is why, we cannot say after crashing whether your total cost increases, decreases, or remains constant. Okay. Now let us see first how to calculate indirect cost. So very much simple. So indirect cost per week. Okay. So assume that indirect cost per week is rupees 700. They have given. Okay. So 700 it is given. So 700 into number of weeks. So what is this number of weeks? So this number of weeks is your project completion time. Okay, so you need 36 weeks to complete your project, right or not? So total indirect cost, you can simply calculate 700 into 36. Done. Okay. Now coming to the direct cost. Now direct cost is not directly given in the question, right or not? Now how to calculate direct cost? How to calculate direct cost? So this is also important point. This concept, till now in the GATE examination they have not asked. So as that's why I have tried to include maximum number of things in this particular question. Very good, Sai Krishna. So the direct cost of the project will be the sum of your normal cost. Okay. So as of now, we are calculating this cost without any crashing, right? We have not done any crashing. So as of now, we have not started any crashing. Okay. So the direct cost incurred will be the sum of this particular normal costs. Okay. So calculate the total sum here. Calculate the total sum. You will get the direct cost. So direct cost will be equal to, so this summation you have to take. Okay, so let me see. 15, it will be 26,000, 26, 28 and 38. So 38, I think 56,500. So maybe, I don't know, orally I have calculated. So please let me know if it is not correct. Very good, Ashutosh. So it will be 56,500. So done. Now your total cost will be 56,500 plus what will be the indirect cost? Total indirect cost will be, so indirect cost per week will be 700 rupees into number of weeks will be 36. So please let me know this value. So some of you have given answers, but I have not, seen them. I mean, I don't know whether it is correct or not. Let us solve this. Okay. Then you can check if you are, if you have done any mistake or not. Right. So Madhu, Smita, you are also saying some answer. So 81,700. Okay. So please, whatever the values which you are giving, I am writing them. If anyone finds any contradiction, if you are getting anything different, you can please let me know immediately. So I think it is correct. So as far as I remember, 81,700, it is correct. Okay. So this is the total cost. Okay. So it is a total cost. If you want to complete your project within 36 weeks. Okay. So within 36 weeks, if you want to complete your project, the total cost will be this much. Now let us go for crashing. Let us go for crashing because we don't know whether it is minimum or not. Okay. So this 81,700, it may be anywhere, right? It may be anywhere. So it may be here or it may be here, here or anywhere. We don't know. Okay. We have to check that. That's what we are doing in the next step. So now we have to go for crashing. So crash activity. Now you just have to look at the things. So which activity have to crash? So I hope you remember the rules for crashing. So rule number 1, always you have to crash the activities which are present in critical path, because that decides your project duration. If you want to reduce the duration of the project, reduce the duration of the critical path. Okay. So rule number 1, crash the activities which are present in critical path. So rule number 2, so whenever you are choosing in critical path, you will be having so many activities, right? You have to decide which activity you have to pick for crashing. So you have to pick that particular activity for crashing, which is having minimum cost slope. Okay. So rule number 2. And rule number 3, if more than one critical path is present, then you have to choose combination of activities for crashing. Okay. Because both the paths are critical. So you have to choose combination of activities. That means from both the paths, you have to pick activities for crashing. Okay. So simultaneously, you have to reduce the duration of both the paths, or more than two can also be present. Okay. So A, B, D, E. Among this A, B, D, E, which one is having minimum cost slope? You tell me. So this is A, B, D, E. So minimum cost slope is for activity E. Very good. So activity E. Now, one more confusion student will be getting is he will be confused whether I have to crash one day or more than 1 day. So that you might be confused. So here the limit is only 1 day, so you may not get any confusion. So if this is 2 days, okay, So if it is, let us assume, if it is 2 days, then you may get confusion. So sir, whether I have to crash it for 1 day or 2 days. Okay. So at that particular time, if you're having confusion, you just crash 1 day. So whenever you are crashing, you just follow this crash only by 1 day. Then you will not do any mistake. Okay. Once you solve some questions, then you will understand. So whenever you are crashing, you have to look for the other path also. Okay. So let us say, for example, I am just discussing few concepts. Okay. I am not solving the question, I'm discussing few concepts. So let us say, for example, if you are crashing activity D, let us say if I'm crashing activity D by 1 day, then the duration becomes 35 here, and there will not be any change here. Okay. But let us say if I crash activity D by 2 days, then what will happen? This becomes 34, but this will be still 35. That means even though you are crashing this particular activity by 2 days, your project completion time is reducing by only 1 day, which is not correct. Okay. So whenever you are crashing, if you want to crash any activity by more than 1 day, you have to look at the subcritical path. Okay. So this is critical path. The next maximum path will be your subcritical path. So a simple name which is given. Okay. So always look at the subcritical path if you want to crash any activity by more than 1 day or 1 week, anything. Okay. So in this question, there will not be any problem. I will be crashing this particular activity E by 1 day. So let me update. So this becomes 0. Okay. So if I crash this, it becomes 0. Then what will happen to this? If I crash activity E, then this by 1 day I'm saying. Okay. So only 1 day we are crashing because limited. So if I crash it by 1 day, then what will happen? This becomes 35 and this will become 34, right? Because activity E is present in both the paths. So in whichever the path this particular activity E is present, so the duration of all those paths will be reduced by a single day. Okay. Now, so let us see. So crash activity E by 1 week. So here it is given weeks. So please don't get confused if I mistakenly take day. Okay. Now you see what will be the total cost. So initially, without any crashing, your total cost was 81,700. Right or not? Now, whenever you are crashing, so if you want to crash this by 1 week, what will happen? What is the additional charge? So additional charge will be 500 rupees per week. Okay, so this also I have mentioned. Sorry. Okay. So the additional charge will be 500 rupees per week. Okay. So 500 rupees per week, we are reducing the duration by only 1 week. So 500 into 1, right? So this will be the additional charge. Okay. But if you see previously the duration was 36 weeks. So we have multiplied 36 into 700. But now what will be the duration? If you reduce this one, it will be only 35. Okay. So you are finding the total cost at the rate 35 weeks. Okay. That means whatever the indirect cost for 1 week, so that much will be reduced, right or not? Minus 700 into 1. Is it okay? Very good, Sai Krishna. Very good, Vijay. So I hope everyone got this point. Okay. So I hope this will be the, I think this will be the best way to, update the total cost. Okay. So previously this was the total cost. So after crashing this by 1 week, additional charge will be 500 into 1, right? And your project duration is reduced by 1 week. Okay. So 700 rupees should be reduced, right? So if I write this one, now you can see on an net, so net change you can see it will be minus 200. Okay, so 500 minus 700 minus 200. So your total cost of the project is decreased. So 81 thousand. So minus 200 if you do, if I do, so it will be 81,500 rupees. Okay. Okay, so Ashutosh, you are asking, so sir, can you please repeat the crashing activity? Okay. So Ashutosh and other students also, if you are having any doubt, so in brief, I am repeating. Okay, so how I have done crashing. So where you are having doubt, Ashutosh, can you clearly tell? That means in calculating this total cost, you are having doubt. So I guess you are having doubt in calculating total cost only, maybe, right? So already rules and everything I have repeated. So you have to choose an activity which is having minimum cost slope. So that we have chosen Okay, so activity E is having minimum cost slope, so crash it by 1 week, so this becomes 35 weeks, and so E activity is present here also, it will be 34. Okay, now see, without any crashing, your total cost will be 81,700, right? So previously, without any crashing, your total cost is 81,700. Okay, so I'm taking same total cost, which is 81,700. Now, as you are doing this crashing of this particular activity by 1 week, so the meaning of cost slope is that only. So if you want to crash any activity by 1 week, so additionally you have to pay 500 rupees. Okay. So as you have crashed this previous duration by 1 week, so additionally you have to pay 500 rupees. So 500 rupees into you have crashed it by 1 week. So that's what I have represented over here into 1. Okay, so if you crash it by 2 weeks, then what will happen? 500 into 2 will be the additional charge. Okay, so 1, that's it. But previously, if you see in this total cost, so we have multiplied 700 into 36 because the completion time previously was 36 weeks, right or not? 700 into 36 times 36 weeks. But now you can see what is your completion time of the project? Only 35 weeks, right? So if it is only 35 weeks, so what will be the indirect cost? So indirect cost should be only 35 into 700. Okay, but previously in this 35 into 36 into 700 is included. So 1 week we have to reduce now. That's what I have done. Minus 700 into 1. Okay, so like this you can calculate the total cost. So I hope, is it okay now? I have repeated the part. Is it okay? So shall I go to the next step then? Got it? Very good. Now you can see the total cost has been decreased. So we have to proceed further. Okay. So we have to proceed further and we have to do crashing. So last step, do not worry, it is not going to be a lengthy question. So crash activity. Now which activity I have to crash, you see? So again your critical path. So your new critical path is same. So this is your critical path. So this is the next path. Okay. Now activity E you cannot crash further. 0. So among A, B, D you have to choose. Okay. So among why it is not erasing? So among A, B, and D, you have to choose. So what is the minimum cost slope among A, B, D? B is also having minimum cost slope, and D is also having minimum cost slope. Now it is your wish, okay? So it is your wish. Now as you are getting a tie, you can choose randomly any activity. Okay, maybe you can choose B, or maybe you can choose D also. It is your wish. Let me choose B only. There will not be any change. Okay, there will not be any change. Do not worry. So let us crash activity B. Okay, so if I crash activity B by 1 day, what will happen? So this becomes 2. Okay, so if I crash activity B by 1 day, then this becomes 2. So what about this activity B? If I crash, so this becomes 34. Okay, so this becomes 34, and as activity B is not present in this path, this will remain 34 only. Now you are having two critical paths. So if you want to perform the next step, so you are having two critical paths, then you have to choose combination of activities for crashing in the next path, in the next step. If you are doing, okay, fine. So crashing activity B by 1 week. Okay, now look at the screen carefully how I am calculating total cost. So previously what was my total cost? 81,500. Okay, previously my total cost is 81,500. So after this again I have done crashing. So if I do crashing, so 1,000 rupees extra I have to pay for 1 week, right? But what will be the reduction in duration? So it will be 34 weeks, right? So if it is 34 weeks, so again I have to minus 700 into 1. Okay, so 1 day duration is reducing. Okay, so indirect cost is 1 week. Okay, so indirect cost is per week, 700 rupees per week it is given. So 1 week, the total duration of the project will be reduced. So 700 rupees will be the decrement. Okay, now you can see net there is an increase. 1,000 minus 700, it will be 300, right? So total cost will be 81,800. rupees. Okay, very good. Now you can see there is a see you can see this one. Okay, so as you are crashing, it is reaching minimum and again it is increasing. So that is what you can visualize. Okay, so what is your minimum total cost? So this will be 81,500 will be your minimum total cost. Okay, and what will be the minimum time associated with this cost? That will be 35 weeks. Okay, so let us see the question, what they have asked in the question, the minimum cost of the project and the associated duration of the project. Okay, so minimum cost will be 81,500 and associated duration will be 35 weeks, right? Very good. So next question, next part of this particular question, you can see if the management wants to complete the project. Okay, sorry, it is not 1 day, 1 week. Here also my mistake. So if the management wants to complete the project 1 week earlier than that of the time associated with the minimum cost. Okay, so if they want to complete this 1 week earlier, that means instead of completing this in 35 weeks, if I want to complete this in 34 weeks, so what will be the additional cost? Anyone? So additional cost will be, how much? Very good. So you can see previously it was 81,500 and the additional cost will be difference between these two. So 81,800 minus 81,500, which will be equal to 300. Okay, so this will be the additional cost. Maybe this type of question can be asked. Okay, but it is a lengthy question. Conventional type of question. But I hope so. If you understood this particular question, you can solve any question which is related to crashing. Okay. So Harsha, you are asking, we have to choose activity with the least cost slope. No, sir. Harsha Somana, we have to choose the activity which is having least cost slope. So that's what I have done, Harsha. So again, the thing depends, right? Now here it is having least cost slope in the second step, but you cannot crash this activity. That's what the new concept which I have told you. Okay. So even though it is having a least cost slope, you cannot crash that. You have reached the maximum limit. So maximum limit is only 1 week. Okay, Harsha. So any other doubts in this? So I am done with this particular question. Okay, so little bit lengthy question, do not worry. And let us take next question, which is related to PERT topic. Okay. So if you're having any doubt related to this particular question, you can ask. Otherwise, we can go for the next question. So next question is, do not worry, not that much lengthy. It looks lengthy, but it is not lengthy. Okay. So let us solve the next question. So from PERT topic also, there was no question. In recent years, very good questions were not there. So maybe this year you can expect a good question from this PERT topic. Okay. So this is also a conventional kind of question, but you will come to know a lot of things in this particular question. Okay. So consider the following project. Find first expected completion time of the project. So in probabilistic projects, we do find expected completion times, right? Second question, standard deviation of the critical path, very much simple. And third question, probability of completing the project within 17 days, right? So let us see, let us solve one by one. So this is the project which is given. So activities are given and description is given and immediate predecessors are given and ABM. So this notation you have to remember, this is a screenshot from a textbook. Okay. Generally this notation will be followed. It is T naught, optimistic time, pessimistic time, and most likely time. Okay. So sometimes it may happen without giving the names, optimistic time, pessimistic time. They may give this notation also. So you should know these two are the different types of notations which they use in the examination. Okay. So Generally, description will not be given to you in the question in the gate examination. Most probably, you cannot expect. Even though if it is given, there is no use of that particular description. Okay, so do not worry or do not waste your time reading the description. We need only activities and predecessors for constructing network diagram. And to find out the expected completion time, we need these things. So it is not given. I mean, units are not given. You can assume them to be in terms of days only. Okay. So in the examination, it will be clearly specified. Okay, do not worry. Okay, so let us draw the network diagram first. Right. Let us draw the network diagram. So activities, so many activities you can see, but not that much difficult network diagram. So let me start a little bit from left. So 1 to 2. So this is activity A, which is not having any predecessor. Okay, so after completing activity A, I have to start BC. Okay, so let me start activity B and activity C also. So as I said, do not represent n nodes. So after completing C, I have to start D. So after completing C, I have to start activity D. Okay, so after completing C, I am starting activity D. Right, and after completing activity A, I have to start activity E. So after completing A, I have to start activity E also. So let me start like this, activity E. So as I said, any type of arc you can use, do not worry. So after starting A, after starting A, this one I have started E also, done. So next, after completing B, okay, I have to start activity F. So after completing B, so let me write it as 4. I have to start activity F. Okay, so after completing C, I have to start GH also. So after completing C, I have to start GH. So let me say this is H, okay, and let me say this is G, right? So after completing C, I have started G and H. So after completing F comma H, so whenever you are having two activities, as I said, join these two at a single node. Okay, so FH you can join at a single node. Let us say this is node number 5. So after completing FH, I have to start activity I. Okay, and after completing I have to start activity J. Okay, I have to start activity J. Done. That's it. Now, whenever you are having, these activities left at the end, so you can join all those activities at a single node. Okay, so let me join all these activities at a single node. This one, and let me name this particular node as node number 7. Now you tell me, can I join this directly over here? Can I join activity G directly at the end node? S, no, S. Okay, so strictly speaking, it is no. You cannot join. So recall the rules of network construction. So no two activities or two or more than two activities cannot have same start and same end. Okay, it can have either same start or maybe same end, but both cannot be possible. Okay, so these two activities DG, if I join directly at the end, so you can see, so D and G are starting, both are starting from 3 and ending at 7. It is not okay. Okay, so this says redundancy, or this, it represents same activities, so that all those things we have discussed in the course. Okay, so whenever you are facing these type of situation, whenever your network construction rule has been violated, you can take a dummy activity. So I know you have to follow the Fulkerson's rule also. Now let me change this particular number to maybe 8. Okay, so this will be D1. So strictly speaking, you cannot do that. I mean, you will be violating the network construction rules. So take a dummy, right? And now maybe one more doubt you will be getting, sir, why we are joining only this G with dummy? So we can join D also, right? We would have joined D also with dummy. It is your wish. Okay, so both the cases are possible. Maybe you can join directly G at the end node and you can take dummy for T. Okay, or you can take this particular case also. You have taken dummy for G and directly join T. So with both the cases, do not worry. Whichever you take, your answer and every parameter, whatever you calculate, that will be same. Okay. So I hope you understood this point, and let us find out the things which were asked in the question. Okay. So let me write E like this. Okay. So what are different paths? A, B, F, I, J. So A, B, F, I, J. Okay. Next, A, C, H, I, J. A, C, H, I, J. Okay. A, C, H, I, J and A, C, D. I can take. A, C, D also I can take. A, C, D I can take. And A, C, G. I'm not including the dummy. Okay. A, C, G. A, C, G, you will get D1 also, as dummy activity carries 0 resource or 0 time period. No need to worry about this one. So you can, there is no need to include this D1 in this. Okay, next A and E. Now I want you to give me the things quickly. Let me name them. Let us say 1, 2, 3, 4, 5. Okay. So maybe you can take the screenshot of the question also in between, as I'm scrolling down. So immediately you can take the screenshot. That will be a good option for you. Okay. Now you see what I have to calculate. I have to calculate, TE value. Okay. So let me write here these in terms of this. Let us see. Now I have to calculate the value of TE. So for calculating TE, you are having a formula A plus 4M plus B divided by 6, right? Now you tell me whether it is a lengthy question. Do you have to calculate these key values for all the activities, or can we say directly what is this TE value? So if you know this beta distribution and all, then you might be knowing this thing. Already there was a question also in previous GATE examination based on this particular concept. So whenever they ask questions, they will try to give these kind of things so that they can reduce your calculation efforts. Okay, very good. Directly. Okay, so do you remember this ABM values will be following beta type distribution. Now your beta distribution, it may be symmetric also. Beta distribution, it may be symmetric, or it may be left skew, right skew, leaning towards left, or maybe leaning towards right. Depends on the values of ABM. Okay, so if you recall, so it is somewhat similar to the normal distribution. So if your data is symmetric, it will look somewhat like this. So A, M, B. Okay, so this difference will be equal to this difference. Okay, so if the distance or the difference between these two and these two are equal, then we can say your curve will be symmetric, right or not? So if it is not equal, then they may lean maybe towards left or right, your beta distribution curve. Okay, so this is one special case, symmetric beta distribution type of curve. So how to identify whether it is symmetric or not? Simply look at this. One more mistake which you will be doing is, most probably in your mind you will be having A, M, B. Okay, so A greater than M greater than B, right? So you will be having in your mind A, M, B, but okay, no. Observe the data properly. A, B, M is given. Okay. So 2, 3, 4. So 2, 3, 4, you can see this is in AP also, or else simply you can say if your data is in AP, that means common difference is same, then you can say that this TE value will be directly equal to TM. Okay, so even though if you calculate using this formula, you will get the same thing. So 2, 3, 4, it is in AP, or common difference is same, this difference between AM and MB. Okay, so 1, 2, 3, okay, so 2, 6, 10. So 2 plus 4 is 6, 6 plus 4 is 10. 1, 2, 3. So 1 plus 2 it is 3, 3 plus 2 it is 5. So all the data you can observe. So 0.5 plus 0.5 becomes 1. So 1 plus 0.5 becomes 1.5. So common difference everywhere it is same. Okay, so no need to calculate TE values separately. Okay, So in the question, sometimes it may also happen directly. They will be giving you these TE values. These two they will not mention. Okay. But in one of the previous GATE examination, they have done this. They have given this type of data where you can directly identify TE as TM. Okay. Now it is your time. Please quickly give me the values of this. Then we will move ahead. Okay. So I have named the paths also. Please quickly give me the values. Okay, so I'm getting values 11.5, 13.5, 14, 11, 16. So please, you can confirm whether these values are correct or not. Okay, 16. Sorry, 6, na? Okay, my mistake. So it is a small screen. Okay, chalo, right? So the critical path duration will be equal to 14 days. Acha, 11, 14, it is reverse. So 11, 14, it is reverse. ACD, let me see. Okay. Right. This only. Now is it okay? So I have changed. Okay, I have changed. Now please confirm. Yes, that. So expected completion time. So your expected completion time of the project. So expected completion time of the project will be equal to 14 days. So generally we use this notation. Okay, we use this notation for expected values. Mu. So in mathematics also you might have observed E of X or mu is often used for mean values or expected values. So expected duration will be 14 days. So you can see maximum duration it is 14. You can assume them to be in terms of days. Okay, so 14 days, the answer for your first question. So second question was you have to find out the standard deviation, right? So how to find the standard deviation? So standard deviation will be equal to under root sum of variances of critical activities. Okay, so sigma value will be sum of the variances of critical activities. So if you want to find out the standard deviation directly, you cannot add the standard deviations. Okay, so already this we have discussed. You cannot add directly the standard deviations because it may be positive or negative, and in mathematics also you might have seen. Okay, so how to find out the variance of any activity? B minus A divided by 6 whole square. Okay, so standard deviation of the critical path or standard deviation of the project, both are same, right? So whatever the activities which are present in the critical path, you find out the standard deviation, sorry, variance values. So under root sum of the variances of the critical activities. So what are critical activities? A, C, G. Okay, so A, C, and G. So 2 minus 4 minus 2 will be 2. So it will be 2, 4, sorry, 2, 8, 4. Let me write. So is it okay? Whatever I have written? And please let me know. 1 point. Okay, very good, Sai Krishna. 1.53. Good. So 1.53. So please do let me know if you're having any doubts in this calculation. So directly you cannot add standard deviations. Okay, so you can add only variances. You cannot add standard deviations directly. So standard deviation of the project will be equal to, or the standard deviation of the critical path will be equal to under root of sum of variances of the critical activities, right? Variance is 7/3. Acha, okay, so variance is 7/3 and standard deviation is 1.53. So I think I have asked to calculate standard deviation only. That's it. Okay. Now you have to calculate the probability of completing the project within 17 days, right? Now you know this probability. I mean, the completion time of the project follows which distribution? It follows normal distribution. The project completion time, it follows normal distribution. Activity completion times will follow beta distribution, and entire project completion time will be following normal distribution. Okay. So if you can see, this will be the value of mu, which is 14 days given, right? But you have to calculate, let us say x is equal to 70, right? Now you already know for normal distribution 0.5, it is symmetric curve. Normal distribution is always symmetric curve. Okay, so this half area will be 0.5 and second half area will also be 0.5, and the area under this particular normal distribution curve represents the probability of completing any particular event. Okay, and you'll be having probability density function, and in fact this is your standard normal distribution. So it is not simply normal distribution, it is standard normal distribution. Okay, so you know probability density function of a normal distribution, 1 by root 2 pi sigma square into e power minus half x minus mu by sigma whole square. So this lengthy probability distribution, probability density function, and in that probability density function, if you take if you write in terms of z, so if you take z is equal to x minus mu by sigma, then you will get standard normal distribution. Okay, so all these are in-depth concepts. Okay, so in course we discuss, not in numericals as of now. So z is equal to x minus mu by sigma. Okay, so which value you have to find? Now you have to find the probability of completing the project within 17 days. Okay, now you know probability of completing the project within 14 days will be 0.5, right? So the probability of completing the project within 14 days will be 0.5. If you want to complete the project within 17 days, definitely the probability value will be more. Okay, so from here, what you have to do, you have to find the value of z. Okay, so to find out the probability, first you have to find the value of z. So after calculating the value of z, you can go to the normal distribution tables and you can identify the corresponding probability value. Okay, so can you tell what will be the z value? So z is equal to x value will be the due date or delivery date given by the customer, or in the question they are saying to calculate for 17 days. Okay, so x minus mu divided by sigma will be 1.5, right? So z value comes out to be, I think approximately it will be 1.97 something. Okay, approximately I'll take it 2. Okay, approximately I'll take it as 2, and I'll tell you a few more concepts which are related to this. So please listen. Look, 0.97. Achha, you are saying final answer. Okay, 0.97 you are saying final answer. That is okay. So please listen. Till now there was no question in the GATE examination, so that's why I have taken this particular concept. So I am expecting a question. Okay, that's why I have taken. And in recent years trend also, if you see, they're asking questions from some untested topics also. So maybe if they want to ask a question, they can definitely ask from this particular topic. Okay, so if they want to ask a question from this particular topic, definitely you cannot remember all the values of probabilities, right, which are corresponding to z value. Like if I ask you what is the probability at z is equal to 1, z is equal to 1.5, 1.6, 1.7, a lot of values definitely you cannot remember. So most probably if they ask you any question from this particular topic, they will provide you normal distribution tables. Okay, so it is online examination. So definitely they can provide standard normal distribution tables in the examination. Okay, so in worst cases, say for example, they have asked a question and they have not given you the standard normal distribution tables. Maybe they will give some data in the question itself. Okay, like in thermodynamics and some other, you will get some steam tables related data, enthalpy, entropy values kind of data, right? So similarly, you can expect some tables data which will be given in the question. Okay, this is the second case. So third case, again in worst situations, more worst situations, they may ask you questions which are related to simple z values. That means, when z is coming out to be 1, or z may come out to be 2, okay, or z may come out to be 3, right? So if possible, okay, if possible, you try to remember the values of the probabilities for this particular data. So if z is equal to 1, z is equal to 0, already you know it is 0.5. So from here we are calculating, okay, so from here to any other value. So from here to z is equal to 0, okay, z is equal to 1, z is equal to 2, 3, so on. So that's what we are calculating. So from this end, we are calculating the probability values or area value. Okay, so if z is equal to 1, as far as I remember, it is 0.84. Up to 2 decimals I am writing, okay. It will be 0.97 probability. Okay, and this will be z is equal to 3 will be 0.99, I think. So up to 2 decimals I am saying, right? So this will be the worst case. So in the worst case, they can ask these type of questions which are related to simple values. Okay, so again, if you know these values, you can find out for z is equal to -1 also. Z is equal to -1 also you can find, because this 0.5 area you can play with the areas over here. Okay, so for z is equal to -2 and z is equal to -3, similarly you can find, as you know, total area is 1, so 1 minus some areas you can do and you can find out. Okay, now why I am telling this is, the reason is, in engineering services examination they will not provide any data, neither in the question or standard normal distribution tables will not be provided to you in the examination. Okay, so in the question also they will not give any data like this, like stream tables data and all. They will not give any data, but they will give very simple questions where you have to remember these values. Okay, so worst situations, if it happens, then they will ask these type of questions related to simple data only. Okay, so I hope you understood this particular concept. Is it okay? Any doubt in this? And your range will be very much free range they will be giving. That means up to 3 decimals, 4 decimals they will not give. If they give some tables, they may ask you to write exactly, but if they don't give tables, then you will be having very good amount of range. Okay, chalo. So any doubt in this? If you have any doubt, you can ask. Otherwise I'll go to the next question. So with this I am done with network models. Very good, Sai Krishna. So let us go to the next chapter, which is linear programming. So in linear programming, let us solve a small question. Now I think you have solved 2 big questions, I mean lengthy questions. So let us solve a very small question. So let me tell you the important topics of this particular chapter, linear programming. So in linear programming, graphical method is very, 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 very important. Okay. In most of the times you can expect questions from the graphical method, right? Types of solutions, or simply they will be asking maximum value and minimum value. Okay, graphical method is very important. Then comes your simplex method and duality principle and all. So if you are done with graphical method, then you can go for remaining methods. Okay, and next comes your transportation models and assignment models. Okay, so from these 2 topics, very rarely questions will be coming in the examination, but still I think I have taken a question from assignment model because they have started asking questions from these topics also. Okay, but very rarely they will be asking questions, but still we will solve a question. Okay, so these are the important topics. As I said, graphical method very important. So after that you can go for simplex, and from duality principle you can see in past 30 years there was only one question, that too in 2018 ISC Bangalore has asked a question. Okay, So important topics I have conveyed it to you. So accordingly, you plan your revision and preparation. Okay. Chalo, let us solve this question. It is a very small question. Directly, they can ask this as a 2 marks question in the GATE examination. Okay. But you will learn a new thing from this question also. As there are only two variables, directly you can solve using graphical method. Okay. Use graphical method and try to solve this particular question. So directly you cannot plot the inequalities in the graph. So if you want to plot these inequalities, first you have to plot the straight line. And then you can identify the region satisfied by this particular inequality. Okay. So to plot a straight line, we need at least 2 points. So how can we get 2 points? Put x1 is equal to 0, you will get some x2 value. Put x2 is equal to 0, you will get some x1 value. Right? So proceed and try to solve it. I'll also be solving along with you. And please confirm whatever the values which I'm writing, whether they are correct or not. If there is any discrepancy, you can let me know. Okay. So these are the points. Now, if you observe the points, you have got some negative values also. So I am taking 4 quadrants so that negative values will also be covered in this, right? Let me plot a graph somewhat like this. Okay. Let us say on x1 on x-axis I am taking x1 and x2. Okay. Let us plot these values 0 comma 3.33 0 comma 3.33 x1 is 0 and x2 value will be let me write like this 0 comma 3.33. Okay, so this is 1 point. One more point will be 0 comma minus 10. So 0 sorry. So first one, I am so sorry, my mistakes. I have done some mistake here. So why I have written like this? So if I put x1, so this is correct. So this will be x2. If I put 0, x1 will be minus 10. Okay, so it will be minus 10 comma 0, right? Minus 10 comma 0. Nobody has told. Sorry, solving or not? So x1 will be minus 10. So somewhere here, right? So I think maybe you might have not looked and you are solving. Okay, so I understand. I can understand. So minus 10 comma 0 and 0 comma 3.33. Okay. Now, so whenever you are getting some points which are in other than first quadrant, so most probably you might have seen the points only in first quadrant. But in fact, if you see these points in other than first quadrant, what you can do is you join these 2 points and extend the straight line into the first quadrant. Okay. Now, why? What is the reason? So the reason is x1 comma x2 should be greater than or equal to 0 always. Okay. So what are the questions which we come across in our GATE examination in our syllabus? So in all those questions, it will be x1 comma x2 greater than or equal to 0. So maybe if you go into some post graduation level, you will come across some different types of things also. So where x1 or maybe x2 will be having some unrestricted sign and all that is not there in our syllabus. Okay, do not worry about all those things. So always, as far as our GATE examination is concerned, this will be mentioned x1 comma x2 greater than or equal to 0. Okay, so see, straight line, it will be a straight line. That means to any quadrant or to anywhere you can extend. Okay, so just you need 2 points. So one of the points was negative, so no issues with that. You extend it to the first quadrant. No, Sai Krishna, it is not correct, I think. Please check. So let us see 0, 6 and 6, 0. 0, 6 will be somewhere over here. Okay, 0, 6 and 6, 0 will be somewhere over here. Okay, so join these 2 points with the help of a straight line. I'm not showing the region, okay, satisfied by the straight line. That we will see, okay. Let us plot all the constraints first. So next, 0, -2 and 2, 0. So 0, x1 value is 0 and -2. Okay, so it will be somewhere over here, 0, -2. And what about next point, 2, 0? Okay, 2, 0 will be somewhere over here, right? Join these 2 points with the help of a straight line. So if I join these 2 points with the help of a straight line, I'll get somewhat like this. Okay, so now you have to identify the region. So Ashutosh, it is not correct, I think. Please check again. We have to identify the region satisfied with these constraints. Now, if you look at the constraints, all the constraints are of less than or equal to type. Okay, so all the constraints are of less than or equal type. It is less than or equal type. It will be towards the origin, generally we say, or simple shortcut which I have told you. Which I follow is you just substitute origin. Okay, so if origin is satisfied by the constraint, then it should be the region should be towards the origin. That's why it has satisfied. Okay, so you substitute the origin in the constraints. If origin is satisfied by the constraint or satisfied by the inequality, then the region will be towards the origin. Otherwise, it will be away from the origin. Okay, so see first one, if I substitute origin in the first constraint, so it will be 0 less than or equal to 100. That means true. 0 less than or equal to 10. Okay, which is true. That means the regions should be this one. Which one? The region should be towards the origin. So region should be towards the origin, towards the origin, towards the origin. Okay, or down of the in downward direction to that of the straight line. Okay, so that's why origin will also be covered in the region. So similarly, you can identify. Yes, Sai Krishna. Similarly, you can identify the region for other constraints also. So 0 less than or equal to 6, which is true. That means region should be towards the origin. Okay, so it should be towards the origin like this. Okay, so next constraint also you can see 0 less than or equal to 2, which is correct. So it should be towards the origin. Okay, so maybe somewhat like this, right? So if you see the common region between all these constraints, I think this will be the common region, right or not? So this will be the common region. Okay, so I hope you understood this, and let me name these points. So let us say this is O, A, B, C, and D. Okay, so point O will be origin 0, 0. Now you have to let me know what are these points A and B. Okay, so what is point A and what is point B? Achha, point A, it is 0, 3.33, 0, 3.33. So point B and point C, I don't know. So please let me know point B and point C. And point D, I think I know point D, which is 2, 0. 2, 0. Okay. So after this, you can calculate the value 0, 0, 0, 3.33 and Z value at, and so on. So B value is 2, 4, 4, 2. Okay. So 2, 4, and this will be 4, 2. Right. Now please give me the value of Z. 2, 4. Here it will be 4, 2. And Z value, here it will be 2, 0. Okay. So I think it is minus x1 plus 2x2. minus x1 plus 2x, right? So this will be 0 and 6.66, I guess, right? So minus 2 plus 8, minus 2 plus 8, it will be 6. Okay, so minus 4 plus 4, it will be 0. This will be minus 2, right? Now please check the values. What is the minimum value? I think Z minimum they are asking in the question. It is equal to minus 2. Okay, so Z minimum value they are asking in the question, it is equal to minus 2. Now maybe in the examination you may get confusion that why it is not 0. We don't know. Practically it is not, that much relevant. Okay, so negative Z value, negative profits, or any other thing, negative cost, anything. So practically in very few cases you may see this type of situation. But okay, so whenever it is asked to whenever a function is given, if it is asked to find out the minimum value or maximum value, so along with the sign you have to consider. Okay, so say for example minus 2 is present and minus 4 is also present, then minus 4 will be your minimum value, right or not? So this is what the concept which I want to tell you through this particular question. So till now there was no question where you are getting some negative values minimum. Okay, so it may happen. Okay, so this question also I think I have taken from some textbook only, right? So mostly all the few questions I have taken from textbook, few questions I have uh, modified according to the concepts, right? So understood this part. Any doubt in this you can ask, otherwise I'll go to the next question. So I hope everyone is understanding well. That's why I am not getting much doubts. Yes, okay, very good. So let us move on to the next question. One more question I have taken from same graphical method only, but this is little bit different question, because in GATE also previously when they used to ask linked answer type questions, okay, they used to ask these type of questions in GATE. So it is possible, it is expected in future GATE examination they may ask this type of question also, where objective function constraints are directly not provided to you in the question. You have to frame objective function and constraints from the given data of the question. Okay, so let me do this. I think now it is clearly visible. Read the question and try to write constraints and objective function for the given question. So once you write constraints and objective function, it will be very much simple. Okay, you can use simply graphical method and you can solve the question. Okay, so this is your fourth question. So similar type of questions previously, as I said, they used to ask in the GATE examination through linked answer type questions. That means you can say this question carries 4 marks. Okay, so for first part 2 marks and for second part also it is 2 marks, something like that. Okay, previously they used to ask some conventional type of questions also in GATE in 2000 2001 at that time. So they used to ask these type of questions for 5 marks questions. Okay, so try to solve it. So please first write down objective function constraints correctly. Then the problem will be very much simple. Okay, so writing objective function constraints, that is the difficult part. So I'm just reading the question and I'll try to explain, what they're asking in the question. Let us see. There are two products, okay? Two products, A and B, are to be manufactured. So 1 unit of product A requires 2.4 minutes of punch press time and 5 minutes of assembly time, right? And the profit for product A, it is given as 0.6 per unit. And 1 unit of product B requires 7 minutes of punch press time and 2.5 minutes of welding time, right? Next, the profit for product B is 0.7 per unit, so very less profit. Okay, so in paise. Next, the capacity of the punch press department available for these products is given 1200 minutes per week and so on. Okay, and welding time, welding department has an ideal capacity. It is not ideal, it is ideal capacity. Okay, and assembly department has 1500 minutes of time per week, right? So these are your constraints. Okay, so how you are framing. Okay, so objective function, it is very simple, right, Sai Krishna? So constraints will be a little bit, you may get confusion, so please listen. I'll tell you an easy way how you can do this. So whenever you are getting these type of questions, the very first step which you have to do is you have to identify the decision variables. Okay, so whenever some data is given and if they're asking you to convert or to solve an LPP related to this particular data, so the very first step which you have to do is you have to identify the decision variables. So decision variables are those variables finally you are going to decide them, right? After solving the problem, you are going to decide them ultimately. Okay, so what are the decision variables here? You can see there are two products, A and B. Okay, so finally you have to decide how many number of units of A I have to produce and how many number of units of B I have to produce with the available resources such that my profit is maximum. Okay, so decision variables here, x1 and x2, I can write them as x1 is equal to number of units of product A. Okay, so what about x2? X2 will be number of units of product B. Okay, so the very first step, crucial step, will be identifying the decision variables. So once you got this particular decision variables, x1 number of units of product A and x2 number of units of product B. So ultimately you have to decide these two variables in such a way that your total profit is maximum. Okay, so I'm writing them. Let us say, let me write them as A and B. Okay, so you are producing x1 units of product A, x2 units of product B. Now let us see different things they have given: punch press time, assembly time, and welding time. Let me write them over here. Okay, so it is punch press time, welding time. Let me write, or I think assembly. I'll write first. Okay, so let me write assembly because for first product these two are given. So punch press time, assembly time, and welding time. Okay, now if you look at this particular data given in the question, so product A requires 2.4 minutes of punch press time. Okay, so product A requires 2.4 minutes of punch press time per unit, right or not? See, so A requires 2.4 minutes, 1 unit of product A. Okay, so if you want to manufacture 1 unit of product A, it requires 2.4 minutes of punch press time and 5 minutes of assembly time. Okay, so it requires 5 minutes per unit. Okay, so for 1 unit assembly of product A, you need 5 minutes of assembly time. So regarding welding time, they have not told anything for product A. Okay, so let us look into the product B, and profit is also given. So profit I can write over here. Let me write one more column which is profit. So it is 0.6. Okay. So profit is given 0.6 per unit. Okay. So similarly, let me write this also. 1 unit of product B requires 3 minutes of punch press time. Okay. So it requires 3 minutes of punch press time per unit. Okay. So regarding assembly time, I think they have not told anything. And regarding welding, they have told 2.5 minutes. Okay. So welding will be 2.5 minutes per unit. So simply given data, I am writing it in simple tabular form. That's it. So that we can have a clear picture. Okay. So the profit for the product B is rupees 0.7 per unit. Okay. So it will be 0.7 per unit. Right. Now you can see regarding this assembly time, nothing was told. So it will be 0 here and 0 here. So nothing was mentioned. Okay. So product A requires punching and assembly, it is sufficient, and product B requires punching and welding. Okay. So assembly means, using some rivets, fasteners, bolts and nuts, you will be assembling the things. Okay. So welding permanent joints, right? So those are temporary, these things, and welding, it will be permanent. Okay. So nothing is mentioned. You can take it as 0, 0. So is it okay? So up to this, have you understood the data, whatever I have written? So this will be the simplest way. Okay. So if you start directly writing objective function constraints from the given data, you will get some confusion. Okay. So if you write it in the form of a table like this, whatever I have written, then it will be a simpler way, of approaching this particular question. Right now. So we can say that it is a maximization problem. So why it is a maximization problem? Because profits are involved. So always we are interested in maximizing the profits. So per unit profit is given. So how many number of units of A we are interested in manufacturing? We don't know. We have to decide. Okay, X1 number of units. So total profit on product A will be 0.6 into number of units will be X1 units. Okay. So total profit on product A plus total profit on product B. Okay. So 0.7 into X2. So per unit profit is 0.7. We are interested in manufacturing X2 number of units. Remember? Okay. Now, if you can see further, some more data was given. So let me write it. Let us say this is RHS, and let me write them. So some limitations are given. Okay. So for punching, assembly, and welding, so some time limitation is there. Resources, we can say resource limitation is there. You can see the capacity of the punch press department available for these products is 1200 minutes per week. Okay. So only 1200 minutes are available. Now, what are the profits? Everything you are calculating, it is per week only. That's why simply I have written 1200 minutes. Okay. Next, welding department is having a capacity of 600 minutes. So welding department is having a capacity of 600 minutes, right? Next, what about assembly department? Assembly department is having a limitation of 1500 minutes. Okay. So 1500 minutes is the limitation of this assembly department, right? Now, if you can see this one, how to write the constraints. So 2.4 minute you want, 2.4 minutes of punch press time you want for 1 unit of A. Okay. So what is the total amount of time which you want? X1 number of units you are producing. So 2.4 into X1 will be the total punch press time you need for A. Okay. Similarly, 3 minutes of punch press time for B into number of units of B will be X2. So 3x2 will be the total punch press time required for product B. Okay. But what is the limitation? Only 1200 minutes are available for 1 week. That means total punch press time of product A and product B summation should be less than or equal to this particular 1200 minutes, right or not? So you can take, I mean, maximum you can have 1200 minutes or less than 1200 minutes also, it is okay, right? So if I write the constraint, then it will be 2.4 x1. So 2.4 minutes for 1 unit you required. So x1 number of units. So this is the total punch press time for product A. Plus similarly, total punch press time for product B. So this summation should be less than or equal to 1200, right? So similarly, assembly also you can write 5x1 should be less than or equal to 1500. Okay. And similarly, you can write x2, not x2, 2.5 x2. Okay. So 2.5 x2 should be less than or equal to 600. 2.5 x2 should be less than or equal to 600, and this already we have written. So products also, even though they have not mentioned this one, but it should be greater than or equal to 0. So negative number of products will not be there, right? Number of units will be always positive, or a 0 value also is possible. Okay, so now you can see the problem formulation will be little bit lengthy. It is time taking, but solving will be simple. Graphical method, it is very simple to solve this particular question. Okay, so let me write the points. Put x is equal to x1 is equal to 0. So x2 will be 3 4 12, so 400. Put x2 is equal to 0. X1 will be, I think, 500. Please do confirm this. Okay. So here I will be getting directly x1 is equal to 300 maybe, and x2 will be, please let me know, 600 divided by 25. 240, 240 I think. Ha, right, Sai Krishna, 240. Okay, so this is correct, right? 500 comma 0. So I just have done hand calculation, manual. So let us plot this graph quickly. So the crucial part in this particular question is problem formulation. Okay, so please do ask if you have any doubt in this. So I have tried my best to give you a simpler method. Okay, so if you write the given data in this manner, so directly you can write the equations. Okay, do let me know if you are having any doubts in problem formulation. So x1 and x2. Okay, 0 comma 400, 500 comma 0. So let us say this is 0 comma 400, and this will be 500 comma 0. Okay, so join with the help of a straight line. Right, so x1 is equal to 300. So x1 is equal to 300, maybe somewhere here. So x1 will be 300, means it is a straight line which is parallel to x2 axis. Okay. Okay. This one. So this is your x1 is equal to 300 straight line. So x2 will be equal to 240. X2 will be equal to 240. Maybe somewhere here 240 will be. So 0 comma 400, right? So it will be 0 comma maybe 240 will be somewhere over here. So if I join, it will be a straight line like this. Okay. So this will be x2 will be equal to 240. So it is a straight line which is parallel to x1 axis, right? Now, so then if you can see, it is very simple. All the constraints are of less than or equal to type. So I already have told you one rule. So if it is less than or equal to type, so region will be towards the origin, right? So if it is toward the origin, so this will be your region, right? So let me name the points. I think you have to calculate 2 points. So O, let us say A, B, C, and let us say it is D. Okay. So please let me know all these points. So let me write the points first. So point O will be 0, 0, and point A will be 0, 240, and point B will be 200, 240. Sai Krishna is saying, okay. So 200, 240. So other people, you can please cross check, okay. So what about point C? 300, 160. I think it is correct. 300, 160. So what about point D? So point D will be 300, 0. Okay. So what was your Z value? So Z value should be maximized. I think it is 0.6 x1 plus 0.7 x2. Right or not? Let me check. Right. So this becomes 0, and your Z value here, it becomes 240. So can you please let me know what is this value you are getting? So 24 into 7 you will be getting. So at A, 168. Okay, very good. Quickly, I'm getting answers. 168. This will be 288. This will be 292. Okay, and this will be not 210. I think. Please check. 300, 0, right? So it is 180. I think, right? 210 or 180. Last one. It is 180. Okay. Because 300 into 0.6, right? Okay. So all the values are correct. Then your maximum profit will be 292 will be your maximum profit. Okay. So at maximum profit, product A, how many units you have to produce? 300 units. And product B, you have to produce 160 units. Okay. So if you produce 300 units of product A and 160 units of product B with the available resources, then your profit will be maximum, which is equal to 292 rupees. Okay. So this was the question. You can check what they were asking in the question. So formulate the problem as a linear programming problem. Done. And determine the quantities of product A and B so that the profit is maximum. Okay. So quantities of A and B will be x1 300, x2 will be 160. So this type of question can also be asked in the GATE examination. Instead of asking, maximum profit, they can ask you. So what maximum profit, how many number of units of product A we have to produce, or how many number of units of product B we have to produce, something like that. They can also frame questions. Maybe they can frame some MSQ type of questions also. Okay. So most probably you can expect MSQ type of questions in the form of theoretical type of questions only. But numericals are also possible. Okay. So still they can ask some numericals as MSQs. Okay. So any doubt in this? I hope you understood this particular question. So a little bit lengthy, conventional kind of question only, but still you got to know something new. Okay. So let me take, I think this will be the last question of our session. I'll take one assignment question. Okay. Meanwhile, if you're having any doubts, okay, please you can comment in the chat box. So if no doubt, you can say simply no doubt. Then I'll be jumping to the next question. So I think this is the 5th question of our session, right? No doubt. Okay, very good, Sai Krishna. So I guess this is the 5th question. Right, this is the 5th question of our session. But don't count the questions, okay? I'm just writing the number. Just analyze how many concepts or how many things you got to know and how many things you got revised to you. That is important. Okay. Okay, very good, Vijay. So let us solve this last question of our today's session. So with this, we'll be completing all these topics. Okay. So important topics I just have tried to complete, and other important things already I have told whatever you have to go through first. So please do remember them and try to revise them. Okay. So in the next session, we will see queuing theory and other topics. Okay. So remaining other topics are very simple: sequencing, scheduling, forecasting, and all. Very simple questions will be there. Okay. Now, so from this question also you will learn something new. Maybe I'm hoping that. Okay. So let us see the question. 4 different jobs can be done on 4 different machines. Okay. The setup and takedown time costs are assumed to be prohibitively high for changeovers. So actually this statement is not required. So I have taken from some textbook. So please try to ignore this statement. Okay. Not that much required for you. The matrix below gives the cost in rupees of producing job I on machine J. Okay, so the cost values. So this is your cost matrix. Okay, so if you are machining job J1 on M1, so 5 rupees is the cost, and so on for all other machines also. Okay, so what is the question? Find the optimal assignment. That means which job should be assigned to which machine. So that will be your optimal assignment. And second question will be find the minimum total cost. Okay, so clearly this is a assignment problem. Okay, so jobs are assigned to the machines. Pretty much clearly this is an assignment problem. And one more thing, if you are having any confusion, that means sometimes they will not mention whether the given question is assignment or transportation question. So simply you can see or simply you can look at the given data. If supply and demand values are not given to you, then simply it is your assignment problem. So if supply and demand values are given to you, then it becomes a transportation problem. Okay, so these transportation assignments are, I mean, especially transportation, that Modi algorithm and all, they are very much lengthy. So very rarely a question comes from that. Okay, but still, in 2017 they have asked a question from Modi method, modified distribution method or UV method. So please try to go through it once. Okay. So assignment problem. So what is the algorithm which we use for solving assignment problem? So assignment problems are a little bit simpler when compared to transportation, because we are having only one algorithm, right, which is your Hungarian algorithm, right? So in Hungarian algorithm you will be having only 2 steps. So generally one will be your row reduction and column reduction. Okay, so if you are not getting answer after doing this, then you have to go for one more concept, which is straight line method. Okay, so let us see this. Let me start with row reduction first. Okay, so row reduction, and then comes your column reduction. Okay, let me take a table. So not, so this is sufficient, no need to okay. So I hope this is sufficient. Okay, so what is row reduction? In row reduction, what you will be doing? You have to choose minimum element from each row, and you have to subtract that particular minimum element from all other elements in the corresponding rows. Like, say for example, in the first row, what is the minimum element? So in the first row, the minimum element is 5, right? In the first row, the minimum element is 5, and in the second row also the minimum element is 5. In the third row it is 4, and in the fourth row the minimum element is 3. Okay, so first row the minimum element is 5, so subtract this minimum element from all the elements which are present in first row. Okay, so why we are doing this? The reason is we need at least 1 0 in each and every row, so that's why we are doing this. It comes out to be 0 2 6 1. Okay, so 5 will be minimum, so this will be 3 0 9 minus 5 it will be 4, so 6 minus 5 it will be 1. So similarly, the minimum element in this row is 4. So subtract it from all the elements. So 0, 3, 6, again it will be 3. Okay. So in the next row, the minimum element will be 3. So this becomes 7. 4 minus 3, 1. 8 minus 3 will be 5. 3 minus 3 will be 0. So row reduction done. So similarly, you have to go for the column reduction. So in column reduction, you should not take this matrix, okay? So you have to take this particular matrix. So we need at least 1 0 in each row, and we need at least 1 0 in each column. Okay, so take this matrix and try to apply column reduction. So same as that of the row reduction. Select minimum element from each and every column and subtract it from the corresponding columns. Okay, so in the first column you can see 0 is present, so 0 will be minimum. So even though if you subtract 0 from all other elements, there will not be any change. Okay, so 0 0 3 0 7 as it is you can write. So in the second row also you can see 0, so no change. 2 0 3 1 2 0 3 1. Okay, so in the third row, what is the minimum? 4 is minimum, so this becomes 2 0 2 1 2 0 2 1. Okay, so in the last column you are already having 0, so there will not be any change. So 1 1 3 0 1 1 3 0. Okay, so anyone got answer? So I'm just looking. Okay. So what about the final answer? Okay, so please listen. Let us solve this one. So after doing row reduction and column reduction, what you have to do after getting this particular matrix in column reduction? So the very first step is you have to look for the single zero rows. Okay, so go for the single zero row and do the assignment. So any single zero row you can choose. Okay, so it is a single zero row. Let me assign over here. Okay, so if I assign here, I have to cancel the other 0 in this particular column. So I went for a single zero row, so no other zeros are present. But in the column, whatever the zeros are present, I have to cancel them. Okay, because one job, one machine rule. Okay. Next, so any other single zero row available, I can see this is also a single zero row, so I can assign over here. Okay, so I can assign over here, and there is no other zero in this column, so no need to cancel. Now you can see any other single zero row. No, you are having a row, but in this row you are having two zeros. Okay, so if single zero rows are not available, then you can go for single zero columns. Okay, so this is a single zero column, and this is also a single zero column, so you can choose any one. Okay, there is no issue, you can choose any one. Let me choose this one, so this will be cancelled. Okay, so now if you can see, there is a 4 by 4 matrix, right? We need 4 assignments, but we got only 3 assignments, right or not? We need 4 assignments, but we got only 3 assignments. Whenever you are facing this type of situation, you have to go for straight line method. Okay, so go for the straight line method. Straight line method. So I hope you understood when should you use straight line method. Okay, so whenever your number of assignments are less than required, then you have to go for straight line method. So very simple rule. Okay, so in straight line method, what you have to do, let me copy this matrix. Okay, let me copy this one and I'll paste over here, but again I have to erase the things. Okay, let it be. So in straight line method, the very first step which you have to do is you have to cover all the zeros with the help of minimum number of straight lines. Okay, so try to cover all the zeros with the help of minimum number of straight lines. So this is a trial and error method. Okay, there is no particular procedure that if you draw in this way then only you will get minimum straight lines. It is not like that. Trial and error. Okay, this you have to understand. Okay, so try to cover maximum number of zeros with minimum number of straight lines, or not maximum, in fact it is all the zeros should be covered with the help of minimum number of straight lines. Okay, now definitely with the help of one straight line I cannot cover all the zeros, right or not? So let us see with two straight lines. So two straight lines, let me take a straight line like this. Now why I'm drawing this? Because I found two zeros over here. That's why I just have drawn a straight line covering two zeros randomly. Trial and error method. Okay. Okay. So here also two zeros I have covered. Now only one zero is left. Now any other combination is possible where using only two straight lines, I will be able to cover all the zeros. I don't think so. Okay. So it is not possible. So with only two straight lines, you cannot cover all the zeros. It is not possible. You can try. So minimum three straight lines are required to cover all the available zeros in this particular matrix. Okay, so done. Okay, so after this, what you have to do after doing this step? So in the next step, what you have to do is you have to select minimum element which is uncovered. Okay, so there are two types of elements you can see. Some elements are covered with straight lines and some elements are not covered. So this three elements and six elements are not covered with straight line. So among these six values, what is the minimum value? Minimum value is 1. Okay, so minimum value is 1. So this minimum value you have to subtract from all uncovered elements. Okay, so if I subtract this minimum value which is 1 from all uncovered elements, I'll get this as 1, this also as 1, this will be 0. Okay, so what about this? So this will be 2, 1, 2. Okay, so these six elements I have written. So subtract the minimum element from all uncovered elements. Okay, next. So whatever the elements which you have covered, you have to leave them as it is, and wherever you are seeing intersection, you have to add the minimum element. That means here you can see the two straight lines are intersecting, and here also the two straight lines are intersecting. Now you may say, sir, why can't we take vertical straight lines, sir? It is your wish. You can take vertical straight line, you will get same answer. So this particular horizontal straight line, you can take vertical straight line also, you can cover it. There is no issue, you will get the same answer. You can try after the session. Okay. So wherever you are finding the intersection, so at that elements, you have to add this particular one. So 3 plus 1 becomes 4, 7 plus 1 becomes 8. Okay. So 3 plus 1, I'll write it as 4, 7 plus 1, it will be 8. So remaining elements, there will not be any change. You write them as it is. Okay, so 0, 0, 0, 1, 0. Okay, so do not think I have written them separately, or else. Okay, so I think you can understand this one. Is it okay? Straight line method we have to use, right, Madhusmita? Okay, so you understood this one, right? Now after doing this, now again you go for the assignment. After doing this, again you go for the assignment and check. Now in a similar way you have to do the assignment. So how can you do this assignment? So go for the single zero row. So any single zero row here. Okay, so there is a single zero row. I can go and I can assign here. So other zero I can cancel. Okay, so any other single zero row. So this is a single zero row, assign, and you can cancel this. Right now again you can find, I think again you can see these two, it is a double zero row. Okay, so it is a double zero row, and you can choose any one and you can cancel the other one. Okay, now again you can see 4 assignments you need, but there are only 3 assignments which we got. Okay, so this is a iterative method like simplex method also, you know, that is the iterative method. So it is a iterative method. So do not think that if you are not getting answer in the first after the first iteration it is wrong. Do not think that. It may happen that, you know, after the second iteration you may get correct answer. Okay, so in the gate examination maybe you cannot expect very lengthy question like this, but still they can break and they can ask. You can see simplex method also. They are asking questions from simplex method also by breaking into small parts. Okay, so again go for the straight line method. So again go for the straight line method and again do this. So how can I do this? Let me try straight line like this. So again it is a trial and error method. Okay, I think we need minimum 3 straight lines to cover all the zeros, right? Now again repeat the same procedure. This time I'll go a little bit fast because you know the procedure, right? So select the minimum element. So minimum is 1, right? So minimum is 1. So you have to subtract the minimum element from the uncovered elements. So at the intersection of straight lines, add the minimum element. So covered elements you can leave as it is. No addition, no subtraction. So it is a covered element. I am leaving it as it is. See, 0. So subtract 0, 0. Covered element as it is. Add, it becomes 5. 0, 0. Intersection I will be adding. Okay, so 0 covered as it is. So minus 2 minus 1. 0 covered will be as it is. So covered 8. 0, 0 and 0. So do not get worried with a lot of zeros. Now see. So C1, C4 are 2, 3 lines. Acha, C1, C1 are 2. Okay, understood, Sai Krishna. Okay, now again go for the single zero row. See, there is no single zero row available. Okay, so then look for the single zero columns. So any single zero column is also not available. Now what you want to do, if single zero rows and single zero columns are not available, look for the double zero rows. Okay, so 4 zeros, no need to touch. It is a double zero row and it is also a double zero row. So randomly you can assign anywhere. Okay, so I will assign here. If you want to assign here, you can assign here. No issue, same answer. Okay, so double zero row you can assign here or maybe you can assign here, same answer. So I'll assign here. Okay, so I'll try to assign here, and if I assign here I have to cancel this 0 and I have to cancel this 0 also. Okay, and now again see any single zero row. So single zero row is also not available. Sorry, this one also I have to cancel now. So other zeros in the column, in the row also. Okay, so any single zero row present, again double zero rows are available, single zero row and single zero columns are also not present. Okay, so you can go for double zero row or double zero columns. So let me assign over here and let me cancel this one 0 and this 0 also. Okay, so again you can see double zero rows are available, double zero columns are available. So diagonally any two you can choose. Okay, so you can choose this one and this one. These two will be cancelled, or maybe you can choose this one and this one. These two will be cancelled. Same answer. Do not worry, same answer. Try it. So if I choose this one, then I can cancel this one and this one. So I will be left out with only this. Okay. Now I think some 3-4 multiple optimal solutions you will be getting for this. So this assignment problem is having multiple optimal solutions. Okay, so like in graphical method, simplex method also you might have seen multiple optimal solutions. In a similar way, you will be having multiple optimal solutions here also. So I think this was the answer, right? So total cost will be equal to 11 plus 9 will be 20. 11 plus 9, 11 plus 9 will be 20, 20 plus 3 will be 23. Okay, so you try with other combinations, you will get same answer. Do not worry, you try with other combinations also, you will be getting the same answer. Okay, so these are the things. Okay, so one thing which you can learn from this question is do not worry if you are not getting answer after the first iteration. So from after the second iteration, you may get answer. So maybe in the gate examination, it may happen. So they will be giving you some in between solution, and they will ask you, so perform further iterations to get optimal solution, or check whether the given matrix is optimal or not. Something like that. They can frame questions. We don't know. That's why you should be aware of this thing also. Okay. So one more thing is multiple optimal solutions are also possible. So whenever you are getting a time, randomly you can choose any 0 for assignment. You will get the same answer. Okay. So do not worry. Right. So we are done with this 2 chapters, and remaining chapters are very much simple that we will be seeing in the next session. Okay. So I hope you enjoyed this particular session, and you are having the schedule. I think next session will be in tomorrow itself, same timing, 2:30, I guess. Please go through the schedule. Okay. So we'll be meeting in the next session. Please do prepare well. Do not waste time. So we are having very limited amount of time as of now. At the end, you are having. Okay. So I hope you enjoyed this particular session. Please do like and share with your friends who are preparing for the GATE examination or any other competitive examination in which this industrial subject is present. Okay. So meet you in the next session. Bye bye. Take care and prepare well.